Welcome everyone to the December edition of the COMSOC video seminar. Today we'll have two talks on somewhat more empirical topics. We start with David McCune of mathematics at William Jewell University in Missouri, who will talk to us about ranked choice voting methods.
And thank you, Dominic, for inviting me, and thank everybody for coming. Everybody, wait, am I sharing just the slides or am I sharing also people's faces?
No, we can only see the slides. Looks
Okay.
good.
Okay. So this project was done last year. It was run through the Institute for Math and Democracy at Wellesley College. Just thinking about taking advantage of all the recent explosion in ranked choice ballot data that's available nowadays. So like 5 or 10 years ago, if you wanted to look at ranked ballot data from real elections, your options are very limited. But with the increased adoption of methods like instant runoff voting and single transferable vote nowadays, and with more jurisdictions making ballot data available, you can grab ballot data from thousands of elections and sort of see whatever you want to see from it. Oh, here we go. Okay, so basically the idea of this project was we're going to gather as much ballot data as we can from as many real world elections as we can and just do classic social choice stuff. So, thinking about Condorcet winners, spoiler effects, strategic voting, things like that. That's what we did. Um, we had a team of 8 people listed here. So I was co-PI along with Ismar and Andy. They're the co-directors of the Institute for Math and Democracy. We wrote a technical report that's available at this link. We haven't written up any academic papers yet. We're still kind of refining the scope and thinking about what to write. But if you want a flavor of the results, they're at this link here. Okay, so a few disclaimers. I just want to emphasize up front, of course, it's not our idea to think about what voting method is best or something, right? Or even to use real world ballot data. So our main contribution, I think, is gathering all this data in one place and then analyzing it sort of as one. Also, we created some algorithms for analyzing strategic voting, which we think are pretty cute. Our algorithms probably won't impress the computer scientists in the audience, but we thought they were useful and gave us some good information about the methods. And of course, also the ballot data is collected under a given voting method. So instant runoff voting or single transferable vote are the main ones. So if you were to use Borda count or something, of course, the ballot data might change. We have nothing to say about approval voting or range voting, only ranked methods. And yeah, these are preliminary results. We're still kind of refining what we want to say. Okay, so let's start with the data that we gathered. And when I say we, I mean other people, of course, did a bunch of legwork. So this isn't all us, but we sort of brought this into one place. And I want to spend just a tiny bit of time on this because uh, my impression is that most people don't know that these repos exist, or at least not all of them. So the first data set we use was this is the Fair Vote data repo hosted by the Harvard Dataverse. So this repo consists of the ballot data for every American ranked choice election for which ballot data is available. So mayoral elections in San Francisco, Minneapolis, federal elections in Alaska and Maine. And this repo has only been public for like 2 years. Prior to 2023 or 2022, people like me had to just collect all these cast vote records ourselves, and it was extremely tedious. And dealing with election offices is very obnoxious. Anyway, so FairVote does that work now and makes it public. If you want a sample of where this data set's been analyzed, there's a bibliography at the end. This is not comprehensive, just a sample, 3, 4, 5. The next data set is a data set of Scottish local government elections collected by me, as far as I know, and now available at this link here. Some articles where these were used. This data set consists of multi-winner STV elections mostly, so it's not clear what utility these elections have for single winner analysis, but it's still ballot data from real elections, political elections. But since these elections are multi-winner, we also created this data set that we called Scott Condensed. And basically what we did was we tried to take the multi-winner elections and make them more single winner-like by keeping only one candidate per party. So in these original elections, Labor might run 3 candidates. They probably wouldn't do that if we were electing a single candidate. So we just take the strongest of the three, keep them, delete everybody else, and get ballot data that way. So, it's not clear if that's like the best thing to do, but it's a thing to do. Seems not unreasonable. And then we grabbed the Australian elections data set. These are Australian cast vote records from New South Wales and Victoria. The New South Wales elections are available now at PrefLib. The Victoria ones were collected by Nick Stephanopoulos and analyzed in this Article 8. So these are available if you want them, but I don't think the full data set is publicly posted somewhere. So that's the data that we collected. We also asked Andrew Myers at Cornell for ballot data from his online voting service. He's a Condorcet voting guy, so he created a platform where you can run Condorcet elections if you want to. These elections are not political. It's not even clear that they're real in any sense. Like, do you care about elections where friends are voting on movies? But anyway, so his service has, or the ballot data has something like 23,000 elections in there. We only kept a small subset because we didn't care about elections where 5 people vote on 20 things. So we kept elections with at least 3 candidates and like, I forget the conditions, but at least 5 times as many voters as candidates, things like that. Anyway, so those are our sources. The methods we analyzed, as all of you know, there are hundreds of ranked methods that have been proposed, many of them with proponents who, think we should use them for everything. So we can't analyze everything. So we focused on voting methods that are being used or have been used for political elections, or methods that get a lot of play in the theoretical literature, like Condorcet methods, like Borda count. So our list of election methods was plurality, so most first place votes wins, instant runoff voting, top 2 instant runoff voting. So you take the top 2 plurality winners and then make them go head to head in one runoff round. A host of Condorcet methods, Bucklin voting. I like this method because it was used in the US in the 1920s in several cities. And then we wanted to use Borda count because real world data has a lot of partial ballots. You have to decide how to handle partial ballots. So we chose these three. These seem like the 3 most popular ways to process partial ballots for Borda. So the optimistic model, pessimistic model, average model. Under the optimistic model, you're as friendly as possible to candidates who aren't ranked on a ballot. Under the pessimistic model, you're as unfriendly as possible to candidates not ranked on the ballot. If you're not ranked, you get nothing. Whereas if you, under OM, if you're unranked, you get the maximum amount of points available to like the next rank. And then the average method, you hand out, if your point scheme is like 3, 2, 1, 0, whatever, you hand out the 3, and then if there's whatever points are left, you average them across the unranked candidates. So average is kind of like middle friendly to unranked candidates on a ballot. Anyway, so of course, there are other methods we could have analyzed. We also wanted to focus on methods where their definitions can be easily adapted to partial ballots. So something like Coombs' method, in my opinion, isn't really like that. Anyway, so these are the methods that we decided to analyze. So let me now give you a sample of our results. So the first thing you would do, I think, is look at how often do you elect the Condorcet winner. So by data set, here's what you get. So nothing here I think is surprising. IRV does pretty good. So high 90s most of the time. The only place IRV kind of falls down a little bit is in the Civis data set, but those elections are kind of nuts. Like I said, they're low stakes, not political, people just voting on whatever. So 83.6 is probably an absolute worst case Condorcet efficiency for IRV. But anyway, nothing here is surprising in that IRV does pretty good. Plurality does poorly relative to the other methods most of the time. Borda OM, this optimistic Borda method, the Australian data doesn't work nicely with that method. The truncation that voters engage in those elections is strange relative to the other data sets. So I don't know why this number is the way it is, but it's also worth pointing out, I had always been told in Australian elections, voters are forced to cast complete ballots, which is true for some, but not for New South Wales local elections. So there are tons of partial ballots in those elections. Anyway, so the main takeaway here is not surprising at all. If you like Condorcet winners and you're not going to use a Condorcet method, IRV does the best. This is unsurprising. The next thing we looked at was spoiler effects. So by spoiler effect, I mean what most people mean, which is that an election demonstrates a spoiler effect if there exists a losing candidate, such that when you remove them, the winner changes. So here's just the raw count of elections with a spoiler effect. This is in the US. So there's 402 total elections. These methods at the bottom are just our Condorcet methods that we use, like minimax, Smith minimax, and so on. The definitions don't really matter here. They're just all Condorcet methods. So these Condorcet methods are returning a spoiler effect in elections where there's no Condorcet winner. There was a Condorcet cycle at the top, so it's unavoidable there. So this is like kind of the bare minimum that you would see. If there's a Condorcet cycle, you're going to get a spoiler effect no matter what. Anyway, the main takeaway, this again is not surprising. Plurality does poorly. Various Borda methods do poorly. Bucklin does poorly. Besides Condorcet methods, IRV does the best. This again is not surprising, but it's nice to have a quantifiable number here. Here are the results for the Scotland data set. These are the uncondensed ones. So these multi-winner elections, if you got 10 or 11 candidates running around, including 3 Labor candidates, 2 S&P candidates, you're going to get a ton of spoiler effects under plurality. So like half the data set, like 500 out of 1100, gives you a spoiler effect. So, it's not clear how useful this is. When you go to the condensed data set, the numbers get relatively much smaller. But it's the same story. Like plurality, Bucklin, especially Borda OM of the Borda methods do poorly, and then IRV does the best of the non-Condorcet methods. So this bar is kind of high, but it's like 45 out of 1100, so the percentage is not so bad. We also thought about cloning, so as a sort of a lens of examining the spoiler effect, so as a lens of examining vote splitting and things like that. So most of you know these definitions, but just to quickly go over, 2 candidates are clones if they appear next to each other on every ballot. And so what we did was we went to the data set, all 5 of them, and cloned every single candidate. And by cloning a candidate, I mean the ballot data exists. You choose your candidate you want to clone, and then you go through the ballot data and add a new candidate, a dummy candidate next to them on every ballot. And then we just checked for violations of this independence of clones. And so loosely speaking, so this is a very loose definition here, but basically you're independent of clones if whenever you clone the winner of the resulting elections is either the original winner or the clone. So depending on how you clone the winner, the new clone might be stronger than the winner. So you don't want to rule out the clone winning. And then if you clone a loser, you don't change the winner. So we decided to implement methodology like this to hunt for potential violations of this criterion, just to see. I mean, it's all relative. You want to see which methods perform better than other methods. So for every candidate in an election, and for each proportion in this list, so this proportion here is controlling how strong the clone is. So when you walk through the ballot data and you want to clone somebody, you have to decide, do you put the clone above them in the rankings or below them? And and this is the proportion of above. So if you set P equal to 0, your clone appears beneath you on every ballot. If you set the P to 0.5, the clone appears above you on half the ballots. Anyway, so we just ran this and then asked how often do we see the winner change? And how many elections do we get a winner change from something like this? And here are the results. So what's happening here is the bottom axis is the p-value. So this is 0.0 means the clone always appears beneath. So let's just pick one of these curves and see what this is saying. So with plurality, if I clone you by putting a candidate beneath you, that changes nothing because plurality only cares about first place votes. So if we clone candidates by putting them beneath, that changes nothing. So we get no elections where that makes a change. But in like 11% of the elections, if I make the clone slightly stronger by placing them above on 10% of the ballots, then now in 11% of elections, we get a winner change. So we see some sort of clone effect. And what's happening here is that when you clone the winner, you're making the winner weaker, you get a winner change in 11% of the elections. And so notice as we keep making that clone stronger and stronger, plurality returns more hits. One thing I like about this picture is that it illustrates for which methods is cloning good for you versus bad for you? So if your curve goes up, like plurality's curve goes up, and top two IRV go up, for methods like that, you don't want to be cloned because they're sucking support away from you in some sort of vote splitting kind of scenario. For the curves that go down, you do want to be cloned there. So under a Borda method, if you can create a clone that's just beneath you on all the ballots, they're just boosting your point totals. So if a Borda method is used, and this is well known, right? There's no surprise here, but if you're using some sort of Borda method or a Bucklin scoring method, you want to be cloned. It increases your chances of winning. So here are the results for America. We get a lot of hits for Borda. This is 55% of all American elections create a winner change. Here's the picture for Australia. It's the same story. We get the same story no matter which data set. The numbers change a little bit, but Borda, OM, and plurality are the standouts. Something like IRV is not susceptible to this. Finally, I think I'm almost out of time. So finally, we looked at a bunch of strategic voting kinds of things. So here's a sample of that. We basically asked for which voting methods can we quantify the extent to which candidates have an incentive to tell their voters to cast short ballots. So if I'm a candidate, do I want to tell my voters, hey, just rank me and nobody else, or do I not care? You know, so to investigate something like that, we instituted these two algorithms, looking for voter blocks who could engineer a better outcome for a candidate through truncation. So for each losing candidate, we looked at all ballots like this with the loser on it and chopped right where the loser was. That was one algorithm. We also looked for all ballots where the loser is ranked over the winner and chopped the ballot right where the winner is. We did this for all ballots. We did it for like proportions of ballots. So what I'm going to show you next is for all ballots. But so here's the results of that. So these are the percentage of elections in which this kind of truncation thing made a difference. So like this 16.9%, for example, that's saying that in 17% of the Australian elections, we could find a voter bloc who could turn a loser into a winner by truncation, creating a better outcome for this loser that they liked. And so basically, the higher these numbers are, the more incentive candidates have to encourage short ballots. And so under a method like Borda PM, where the highest numbers are, if you want to use that method, you're just encouraging candidates to cast short ballots and also encouraging candidates to tell their voters to cast short ballots and then encouraging voters to cast short ballots. Bucklin also really high. Okay. So I think I'm about out of time, so I'll skip all this. We also did some like negative feedback loop kind of analysis, like when you get retaliatory strategies going. So you can imagine candidates engaging in a battle of truncation or something. Anyway, so this is just a sample of what we did. We did way more than this, but it's only 20 minutes. So if you want to see the full report, it's at that link at the beginning. But basically, the conclusion is not surprising, I think, to most people that IRV and Condorcet do pretty well according to most metrics, and methods like Bucklin don't. Uh, so if you're looking for sort of the best, like an empirical justification of what a best method might be, IRV and Condorcet seem like the two most viable options. And that's all.
Thank you very much. Let's give a round of applause to our speaker. Virtual applause. Klaus Nehring has a question.
I have two questions actually. On one hand, the definition of spoiler effects. In your talk, right after you mentioned clone independence, so I assume spoiler effects is just very broadly any violation of IIA. Is that correct?
Yeah, so very broadly, just anytime you can delete a loser from a ballot data and you get a winner change in the new data.
Yeah, but of course you could say that it's not obvious that's necessarily negative. I mean, in the border accounts, you would say that's part of built in. That's part of the philosophy of border accounts. It doesn't depend.
Well, sure. I mean, that's so the parenthetical comment here. I mean, as I'm sure you know, people debate all the time about what criteria are
Yeah,
important, right? So, yeah, if you think that's not important, or if you think it's a feature, not a bug, then Borda does really well for you because it changes
yeah.
all the
Okay,
time.
okay. Second question is on the CIVS, the data you mentioned on the right column, but you said they're not kind of serious. I mean, they're certainly interesting in the sense they give very different results. I mean, they're not in which, can you explain a bit more in which sense they're not serious, or could one find some interesting aspects? I mean,
So they are interesting. I say they're not serious just because, I mean, they're not political and like just there's no quality control over, well, they can be extremely low stakes. So many of these elections are just friend groups voting on which movie to watch this weekend. So, I mean, that's a real election, but it's not like I wouldn't treat it with the same seriousness as a gubernatorial election or something or a mayoral election. Uh, and also, you get, in these Scottish elections, there's like 10,000 voters and 8 candidates. In these elections, you can have 10 voters and 30 candidates, depending on what they want to vote on. It's just a totally different landscape than what you see in any of these sort of more
yeah.
political driven ones. But sure, it's still interesting. That's why we kept it.
So that could be, but one of the relevant aspects could be if there are more alternatives. Political elections often don't have that many alternatives,
Hmm.
irrespective of the number of voters. Just the number of alternatives is often very small,
Hmm.
and the more alternatives you have, of course, the more complex phenomena you can get. So in that way, I think they would seem to me interesting. Now, setting aside the stakes issue.
Yeah. Uh, and this is a sort of a new data set as far as I know. So they're from Andrew Myers at Cornell. The only analysis I know that he's run on them is he had a paper at the Public Choice Conference about just analyzing how often Condorcet cycles arise and things like that,
Hmm.
uh, which is interesting. But yeah, as far as I know, this is the first attempt to try to do something real with this data set. We didn't know, like so whatever was this Condorcet one. Like this 83.6%, what do you do with that number? So that's sort of lower than you would than most people would want. Is that really a bad sign or not? I mean, if these are low stakes elections with friend groups, it's not so bad, I guess.
Okay.
Okay, we
Can
have
I just
another
ask a
question.
question? Oh,
Yes,
okay,
please.
great. Yeah, I'm curious if about the spoiler effect. Does it have to be a clone, or is it the same with someone else with which is not a clone but the spoiler? Is the result the same or different?
Okay, I'm sorry, say that one more time. If so,
Yeah. I want to ask about the spoiler effect.
Mhm.
Does it have to be a clone exactly, or
Oh, no.
would the result be the same with another spoiler, which is not the clone actually
Yeah.
identically?
Well, I mean, so in real elections, you don't see real clones, right? So that's why we had to add
Uh-huh.
them to the data.
Uh-huh.
But yeah, so this is very broad, these results. Just we're looking for any loser. I don't care what their relationship is to the new winner, the old winner, whatever. Um, but this was just sort of a hypothetical, like, well, what if,
Mhm.
if you were to institute Borda, for example, right, then cloning is that a legitimate strategy or not? And it's already basically known to be yes, but now we can quantify it some with these results. But yeah, here these there are no, I mean, there are clone-ish candidates, right? So like in Scottish elections, two Labour candidates would be clone-ish, but you don't see literal clones anywhere.
Mm. Okay, that'll be easier to calculate. Thank you.
Yeah.
Eric?
Yeah. Hi, thanks. This was really interesting. So just picking up on the clones, I'm just curious. So you can also define clones where there's more than just two clones. You could have three clones and so on. Did
Yeah.
you guys think about this, or do you have a sense if you were to add three clones? I realize that it gets a bit complicated to decide like how to place the clones when you have multiple copies of the clones. Is your sense that it would just like for Borda, just amplify the numbers.
Uh, so, well, to answer your baseline question, no, we didn't think about adding more than one. We thought this kind of made our point, I guess.
Mhm.
But I certainly would imagine, I mean, what you're seeing is that Borda is just highly susceptible to this,
Yeah.
which again is like not surprising. People, I think, basically already knew that. But yeah, I would imagine that it would just amplify it. So I imagine
Mhm.
it would just take these lines and make them higher. I don't know that. Uh, and then, with real elections, I don't know if there's anybody on the call who does this, but looking for clone-ish kinds of candidates, like in a rigorous way in real elections, that's something that people think about, obviously. But yeah, like when you look at a Scottish election, if there's three Labour candidates, you should be able, even though they're not literal clones, you should be able to detect that kind of candidate slate. And as far as I know, they're pretty good algorithms to do that.
Yeah.
So you could add like a fourth Labour candidate if you wanted to, and just see what effect that would have.
Great, thanks.
I have a question. You mentioned at the start that you were thinking algorithmically also, like building algorithms for this. What were some examples of questions where this was a difficulty?
Oh, yeah. So you'll notice like something like this. There's no choices being made. I mean, like this is easy to implement, right? Or whatever this other one was, right? So, I mean, generally speaking, any kind of algorithm where and maybe Nisarg knows a lot about this, right? I'm sure there are people on the call that know about this, but anytime you're looking for like specific voter blocks that do a thing for you, that can be really hard to detect. So for me, I didn't get my hands too dirty with this. This was a sub team that worked on this kind of stuff, but I've tried writing algorithms for like hunting for monotonicity violations and things like that. And anytime you're just trying to find and when you don't have a theoretical result that says, oh, just look for this thing, right? Then your job is just to hunt for some out of 10,000 voters, find some subgroup of voters of some size that does a thing for you. Uh, that can be very difficult, and I don't know. There's all sorts of choices you have to make. Some reasonable, some maybe not reasonable, depending on, you don't know what's reasonable or not ahead of time. But so like hunting for non-monotonicity issues, hunting for uh, so other strategic issues besides truncation are like uh, candidate bearing. What kind of algorithm do you want to do to look for that? There's some easy ones you can write that give you kind of worst case. There's some more sophisticated ones where you take into account candidate grouping that are harder. Uh, Compromise voting is kind of hard to look for. Finding a group of voters who would be better off switching the order of uh, their rankings, not to engineer a paradox, but just to get a better outcome for themselves to vote in sincerely. Anything like that, it's just going to be, in my experience. I'm not a computer scientist though, so maybe maybe everything I'm saying sounds trivial to you. I don't know, but for me, that's hard to. I mean, the code just spirals out of control because you're just making choice after choice after choice.
Yeah, I don't think these questions are easy, and many of them are known to be NP hard. Uh, there's François Durand, who wrote to me that he couldn't join today, but he's done some work on finding group manipulations in profiles, and he has a paper where he compares different methods on this, not on your data sets, but on, forget exactly, Netflix type data sets, and there he finds
Hmm.
that and IRV-like rules are remarkably less manipulable than other rules. You're talking of for the results about strategic voting. Did you have IRV there or not? I only saw
Yeah,
single
well, just
IRV.
this particular problem of truncation, IRV is not susceptible to.
Okay.
But yeah, so we have results on monotonicity, compromise voting, or favorite betrayal voting, whatever you want to call it. So yeah, certainly IRV is susceptible to various things. We found that it was uh, not. I guess our results are in line with what you just said. Theoretically possible, but like monotonicity in particular is just I can't imagine voters trying to engineer such a thing ahead of time. So I guess our results kind of just say that when it comes to something like IRV or Condorcet methods, any kind of manipulation, it's like what's the Latin post hoc? Like you see it afterwards and get offended afterwards. But how in the world are you going to do it ahead of time? Whereas with Borda, it's very easy for a voter to make reasonable calculations ahead of time. Like, should I truncate or not under Borda pessimistic? The answer is often, yeah, you go ahead. And it's clear to a voter why that would make sense. Yeah, so anyway, Condorcet and IRV are the most resistant to manipulation based on what we found.
One more question. So I assume in the data set, lots of the elections aren't actually very interesting. For example, if there's one candidate that has more than half the voters ranking them in first place,
Mhm.
then more or less everyone agrees, and there's very little room for paradoxes.
Yep.
Would it be interesting to filter out such elections? Would anything change?
Not particularly. I mean, it just changes your percentages, I guess. So sorry, there's somebody snow blowing outside my office. Sorry if you can hear that. Anyway, so like in the US, I think 330 of these have the property that there's at least 3 candidates and no majority candidate initially, things like that. In Scotland, I think only like 2 or 3 of these, because they're multi-winner, only 2 or 3 have a candidate with an initial majority. In Australia, also, I'm trying to remember, most of them are at least 3 candidates with no initial majority. So yeah, so most of these elections are usable, but yeah, the full data set here, like the US data set, there's something like 600 of them if you just download the thing from the Dataverse, and many of them are just like 1 or 2 candidate elections. So of course, 2 candidate elections might still be useful for cloning, maybe, I don't know. And there's write-in candidates that kind of gum up the works a little bit. Yeah, I don't think our results would fundamentally change if we just decided to filter those out from the get-go. We try to report percentages by like where the denominator is the interesting elections in the paper.
Rob wrote a question in the chat. I don't know whether he wants to say it out loud, but he asked that you notice any interesting manipulability differences among Condorcet methods.
Well, that's a good question. So, I mean, kind of. Certainly the numbers are different. I'm trying to remember what like the best. So like ranked pairs returned this 9.1 is a huge anomaly among. So I'm only showing you one table. We have like 10 of these tables in the document. But I mean, just generally speaking, they're all highly resistant. I think unsurprisingly, Smith plurality, because it has plurality as part of the definition, right? That was the most manipulable. But yeah, I think Smith IRV and ranked pairs did the best overall, and Minimax also did pretty good. So if there was some sort of outlier, it was Smith plurality.
And Peter?
Yes, thank you for your nice survey. I'm curious whether in your data there are elections where people are choosing for parties rather than individual candidates. So a single party may collect several mandates depending on the number of votes you get. Since I recall from my earlier days that for single transferable votes, you actually could damage a party by giving it more first choices.
Yeah.
That's a different kind of manipulation. So do you have elections involving parties rather than candidates?
No. If I'm understanding your question, no. And also, we were sort of tasked with thinking about single winner methods. So that wasn't our focus anyway. I have some other, like a handful of papers, and I'm sure other people do about, well, I think about this data set, the Scotland data. So certainly when you treat those as the original multi-winner elections that they were, you can find examples where a party gets more votes and that costs them a seat, for example. So you can certainly detect that kind of thing in the data. It's rare, but if you look hard enough for it, you can find it.
Okay, thanks.
Thank you very much. Let's send another round of applause to our speaker. Thanks very much. And this is the time for our coffee break. We will have 10 minutes where you can either get a coffee or you can chat to other participants. I will put you in random breakout rooms with a few people each. You can talk, and then we will be back at 47 past the hour.
Can I share my screen?
Yes, you can go ahead. Welcome back, everyone. So it's time for the second talk given by Roberto Brunetti from Paris Panthéon Assas, talking to us about how people understand voting rules.
Right. Thank you, Dominic. Can you see my slides?
Yeah.
One sec. All right. All right. So, thank you everyone for being here, and thank you for the invitation. So this is a project. So this is a paper which was actually published 3 days ago on public choice. So everything happened quite quickly since the invitation from Dominic. But I'm really looking forward to have your comments, given that, I mean, there are new projects being born, and I will speak about it at the end. And they are partially related to this paper, which is co-authored with Antoinette Beaujard, Isabelle Lebon, and Simone Marsilio. In the group, I'm not the expert in social choice, but I do run experiments in the economics, let's say, tradition. And so I think this is where I plug in the project. All right, so first of all, so you know better than me that in the social choice literature there are many alternative voting rules that are proposed by researchers, and these voting rules might have desirable theoretical properties compared to the status quo. Yet, the property's validity will depend on some crucial behavioral assumptions, and yeah, in order to check for these assumptions, we need to go to the data, and the first presentation was a really good example of that. One really basic assumption that we might wonder about is the assumption, the basic assumption whether people will understand voting rules, and in particular, what they will understand within a given voting rule. However, the fact that people will understand a voting rule might be debatable, especially when the information we require people is different from a simple vote, as in some traditional systems, and when aggregation methods are different. However, what we see in the literature is that there is a scant evidence on whether people understand voting rules, and in particular what they understand. So our aim in this paper is, in a way, really simple, and in another way, not so simple. We want to understand whether people understand two voting rules: evaluative voting and majority judgment. Why did we choose these rules? They are similar yet really different voting rules. In both cases, what is required is multi-nominal ballot, so people give different grades to all candidates, and they have different aggregation methods. So in the case of evaluative voting, the candidate which will win is the one with the highest sum or average grade. While in the case of majority judgment, the candidate winning is the one with the highest median grade. Why they are interesting because in the academic arena, they are discussed and defended by different scholars, and also in the public arena, they are used in practice in some cases, but voters do lack experience with them yet. So, for instance, in France, the majority judgment was used in some political cases. So, for instance, the election of the candidate of the left coalition. And so this is why it's interesting to really understand what people understand. And my methodology is different from the first presentation. Because in our case, we use an incentivized lab experiment on voting with controlled preferences. So this is really in the economics tradition. And what is interesting in a lab experiment is that you really bring people in the lab at the university, and you can explain the voting rules really carefully, and they can practice the voting rules, so voting with the voting rules, with examples and context-rich practice rounds. So you put them in the ideal situation in which they really, if there is a misunderstanding, this will be a lower bound of the misunderstanding that we will observe at the national level if we really use the voting rule in a more general context. And especially what we can do in our experiment is to study voters' understanding at different stages. And I will explain what we mean by that in the next slides. So for the literature, I will skip it. I will really go quickly because I don't have much time. But in any case, what we are interested in, of course, is in the empirical literature on voting rules. And what we saw is that there were only few papers studying voters' understanding of the voting rules. And in particular, in each paper, there was a rather limited notion of voting understanding. So our contribution here is to bring up an experimental protocol that can be replicated with any rule you can think about to measure different components of understanding. And more in particular, we are the first ones to test the majority judgment in the lab. So then we contribute to the behavioral social choice literature, where we are interested in those deviations between the theory and the empirical evidence. In our case, what we're gonna do is to test the theoretical predictions on strategic versus sincere voting with evaluative voting and majority judgment, and showing that in both cases, people vote quite strategically in the lab. And finally, I mean, this is more of interest for economists. There's a literature on whether people understand distractions in lab experiments. And yeah, some results that have been found are actually where, like, people found that they were rather driven by people not understanding actually the task they had in front of them. And in our case, I mean, basically, we apply this reasoning to voting rules. And in particular, we assess whether participants understand voting rules, and we observe that there are significant difficulties with really easy notions as the median. So first of all, we need to understand what is understanding a voting rule, and we distinguish 3 levels of understanding in our paper. So first of all, we speak about how to fill a ballot. So in the case of multinomial balloting, like, people need to understand what a grade means and how to provide more or less support to a candidate. There's already evidence on that, and especially in the case of evaluative voting, evidence shows that people do understand how to give grades. They might make more mistakes when the grade scale is larger, but still, this is not a huge problem. And there's also evidence on the majority judgment. So here, our hypothesis was grounded on the previous literature, and our hypothesis was that most participants understand how to fill a ballot with both evaluative voting and majority judgment. The second level of understanding is about votes aggregation. People need to understand how then votes are aggregated. And here the difference between the majority judgment and evaluative voting is that in the first case, the aggregation is based on the median. And in the second case, the aggregation is based on the sum or mean that's equivalent. So what we considered is that with majority judgment, there are at least 3 difficulties for participants. First of all, they need to understand the median, which is a not so trivial concept, a statistical constant for the average person compared to the mean. We compute means every day, while for the median, this is not so evident. The second difficulty is the fact that the majority judgment, so median rules using the median, they don't respect the monotonicity. So if there is a winner and there are new people supporting this winner more than another candidate, it might be that at the end the winner will actually lose the election, because the importance is that both grades that are, like, all the grades that are being given by the new voters are above the median. And finally, there is the tie-breaking rule. So the tie-breaking rule in this paper will not study whether people understand the tie-breaking rule in the case of the majority judgment, but we can consider that this might be a major source of confusion for participants. And this is what we see actually in the open-ended questions that we ask at the end. In any case, what we conjectured is that more individuals understand how votes are aggregated with evaluative voting than with the majority judgment. And third, the importance, the third level of understanding is is about how people will vote eventually and whether they understand how to vote strategically, especially in the case of a laboratory experiment in which people are only interested in winning money, basically. So in the case of evaluative voting, the predictions are clear. People will can vote strategically by using only X-screen grades, while in the case of majority judgment, the prediction was that there would be less strategic voting given that the rule is based on the median. So our third hypothesis was based on the literature, the theoretical literature, and we expected that to see more extreme grades used with evaluative voting compared to the majority judgment. And so now I'll go through the experimental design, which is, again, a lab experiment in which people come to the university, and in the very first step of the experiment, they had to learn voting rules. And so in particular, they had to learn both evaluative voting and majority judgment. And then in a second step, they got to vote under either evaluative voting or majority judgment. That was randomly, the treatment was randomly assigned. So each person in the lab either voted under evaluative voting or majority judgment. And after the voting, they had to answer some comprehension questions about both voting rules so that we could assess whether they understood actually the two rules. And finally, there was a questionnaire to ask some standard questions. So in the lab, basically, every time, in every session, there were 21 voters, and they could vote for 5 candidates. The candidates were placed on an imaginary virtual line from 0 to 20, and every candidate represented a number. So either 1, 6, 10, 14, or 19. Each voter was given a position, so a voter could have been given a position around, let's say, 0, and he could vote for every candidate either under a majority judgment and evaluative voting. So the payoff, so participants were interested in the final payoff, and the payoff for a participant was given by the distance between his position and the position of the candidate which will be elected. So for instance, if a person was at position 0 and at the end of the election candidate 8 would win, then this guy would earn 19 points. So 20, the maximum, minus 1, the distance between the two, so the candidate and the participant. Participants could know after every election their payoff, and they voted basically for three series of 5 elections each. So they could practice. There were some round practices so that they could actually understand what was going on. So as I said, there were 3 series of election. In a first election, the preference distribution was exactly the same, the profile preferences. So each participant had a position on the 0-20 line. And then in a second series, there was a rather tripartition of preferences where many people were given the position between 0 and 2. Some people were given the central positions, and some people were given the right positions. And finally, in the third series, there was rather a bipolarized distribution of preferences. So as I said, the treatments are quite straightforward. In some sessions, people voted with evaluative voting, and in some sessions, they voted with majority judgment. And most importantly, basically what we do after the voting, we asked some questions to people to understand whether they understood how votes are aggregated with both voting rules. And how we did that was to ask give some exercises in which there were 2 candidates, candidate A and candidate B. People could see that every cross was a voter. So for instance, candidate A in the first exercise got 2 minus 1 grade, and then 2 0 grades, and so on and so forth. And so they had to understand which candidate would actually win this election. So there were 3 exercises like this. In the first exercise, they had to count the votes and tell who was the winner. In the second, it was exactly the same. And in the third exercise, there were 2 new voters being added in the election. And so basically they had still to understand who's the winner in this election. So I'm not going to give you the results of these elections, but in the case of evaluative voting, they had simply to add votes, understand which was the winner. In the second case, so in the majority judgment case, again, we have 2 candidates and people had to compute the median. So, for instance, in the first election, the median grade for the first candidate was good, while the median grade for the second candidate was fairly good. So the first one was winning. The second exercise was similar, and there was a winner, which is candidate B. And in the third exercise, there were 2 new voters giving good to candidate A and 2 new voters giving very good to candidate B. So candidate B is receiving better grades than candidate A, but given that the rule does not respect the monotonicity property, it is actually candidate A ending up winning this third election. So, of course, this was done to understand whether people understand the property of the median and whether they would fall for this, let's say, question. And then in the comprehension questions, again, we asked some simple questions on whether on the final score of a candidate, whether it represented the average or the median simply. And so again, this was done to understand whether people see the difference between the average and the median. So in total, we got almost 200 participants, mostly students. And yeah, the experiment lasted 1 hour. This is quite standard in lab experiments. All right, so the first result is about voting. And in order to understand how people understand how to fill a ballot, we measured, as in other papers, the number of inconsistent votes. So this is the case in which a participant assigns a higher grade to a candidate which is more distant from the position of a participant than another candidate, which of course doesn't make sense. It's a mistake basically in voting. And what we see is that most participants never make a mistake as this one. They never cast an inconsistent vote in the case of with both voting rules. The only cases are cases in which there is only 1 mistake per participant, which given that they vote for 15 times is maybe just a lack of attention for 1 second. So our first result is quite predictable in a way. Most participants do vote consistently with both voting rules, and there is no really a difference between the 2 voting rules. So our first hypothesis was confirmed by the data. This is really important because actually in the public debate, when there is a discussion about how people will understand voting rules, most people actually stop to this level of understanding. However, if we go forward and we measure how many correct answers people gave to the questions about vote aggregation, we see that things can get really different. So when we ask, so on the left, questions about evaluative voting, we see that people get around 80% of questions right on average, and there is no difference on whether people try before, so they voted before under evaluative voting on majority judgment. However, what we see is that the understanding of majority judgment is on average lower. And also in those cases in which people voted for several times on the majority judgment before. So our second result, again, is goes along with our hypothesis. And we can see that participants' understanding of aggregation is on average lower under majority judgment than under evaluative voting. So then we digged a bit more in the data, and we could see that actually what is wrong with the what they got wrong was, of course, the monotonicity of the voting rule, so the lack of monotonicity in the case of majority judgment, and they also got wrong the definition of the median per se. So they didn't, they couldn't distinguish the median and the mean. So the second result, so the third result, is that the most difficult barrier to understanding how votes are counted in majority judgment is its definition of median and its implication in terms of vote aggregation. And third, there's another interesting result about how, so the distribution of understanding, let's say, how even is the understanding of both voting rules. On the left, we have questions on evaluative voting, and we can see that the mode is 100% correct answers. So most people understand every question, they understand correctly. And in general, they do not get many answers wrong. While in the case of majority judgment, there's a significant portion of the population which is getting either nothing or really little about the majority judgment. So our third result is that participants' understanding of majority judgment is more unequal than their understanding of evaluative voting. This means simply that some participants have a strong grasp of how votes are aggregated, while others have little to no understanding. And the third level, as I said, is the level of strategic voting. People are in the lab, they are incentivized to win, to think about how to vote in order to maximize their payoff. And here I just plot how people vote in the first election series, just out of simplicity, but it doesn't change in the other series. And what I plot is on the x-axis, the distance between the voter and the candidate. So 1 stands for, this is the closest candidate to me, 2 is the second closest candidate, and so on and so forth. And on the y-axis, you either have the numerical grade of evaluative voting or the verbal grade of majority judgment. And what we can see is that people give the maximum grade to the closest candidate. They tend to give an intermediate grade to the second, third closest candidate, and then they go for the extreme grades, lowest grade with both voting rules. What is important here is to notice is that there's no difference whatsoever between evaluative voting and majority judgment. People vote exactly the same way. And so our third hypothesis was actually rejected by the data. We see that people vote exactly the same way with both voting rules. I don't know if I'm running out of time. The last important result is that we can actually predict how strategic will vote depending on how they understand the vote aggregation properties of both voting rules. And what we can see is that with evaluative voting, no matter what they understand for the aggregation properties, people do vote strategically most of the time. While under majority judgment, we can see that those people understanding how the median works vote even more strategically than other people. So a fourth result is that under majority judgment, there is an inequality in understanding of vote aggregation, and this will translate into the way people vote, so more strategically, when they get to vote in the experiment. So our conclusions quickly. I mean, we build this protocol in the lab, in a lab experiment. That can be replicated with any voting rule you can think about, and we measure different components of understanding. We saw that casting a ballot is not a problem with both voting rules, but actually voters' understanding of the vote aggregation is lower and more unequal under majority judgment, and this translates into the way they vote in the experiment. So those participants understanding more how votes are aggregated will vote more strategically. And this, we argue that can have important implications for voters' agency, because there might be inequality in their understanding that will translate into inequality in voters' empowerment and their ability to reach their objectives. It's important to stress that our results are definitely an upper bound of understanding. So this is a sample of bright students. These are ideal experimental conditions, and we did not even care in the experiment to understand whether they understand the tie-breaking rule in the case of the majority judgment. And so, of course, we can imagine that there might be more misunderstanding in the general population. And finally, just as a little advertisement, we just started a new project, which is called Condorcet, because we are in France, and of course, we need to give credit to Condorcet. The project is about voting rules, and the project will study different properties of voting rules, and in particular, there will be some more experiments going on. I mean, we'll use online experiment and probably also lab experiments with my co-authors Antoinette Beaujard, Théo Denoazur, Jérôme Lang, Isabelle Lebon, and Simone Marsilio. Not all of them in one paper, but yeah, like in different papers. So if you're interested, please do not hesitate to contact us, because we'll be working on different voting rules, such as approval voting and other rules. Yeah. So thank you for your attention, and I hope I was not too late.
Thank you very much. Let's send some round of applause to our speaker. Okay, and we have time for questions.
Yeah, so, yeah, sorry, evaluative voting, yeah, in the paper we say that there are several names for the same rule, but yeah, range voting is another way to put it, yeah. Sorry.
Ole has a question.
Yeah.
Hi, thank you for the talk. I have I think a clarification question, a little bit what you mean by strategic voting. So is it only about making one's judgments or evaluations more extreme than they truly are, or is it also about like inverting the order or things like this? So how did you?
We compute, like, we define strategic voting as the number of times a participant uses extreme grades. So okay. we would expect, yeah, it's simply about the extreme grades they use, actually. Yeah.
Because I think what and when you started talking about the like understanding the voting rule, I was actually wondering whether, because you are measuring like, you know, would this person be able to count the votes for us and announce the result? And that's not the job of the voter. So would another way of measuring understanding be like, does this person understand what kind of vote, what kind of ballot to submit would be in their own best interest? That would be kind of a strategic level of understanding. So do you have something about that? Like, do people understand how to vote in the best way?
Given their beliefs about how other people vote?
Yeah, that's what I mean, yeah.
Yeah, we didn't measure people's beliefs about other voters. This is something we could do in a lab experiment, in a potential new experiment. In this experiment, we decided to define the strategic voting as really as in the paper, the theoretical papers that we cite, in which they show that strategic voting for evaluative voting would be just going for extreme grades. But yeah, of course, this is a good point, which we could potentially also measure beliefs. But the experiment was already long, and we decided to go for this easier solution.
Thank you.
Thank you for the question.
Peter?
Yes, it may be a related question. You told us that the candidates were fully informed, but from the answer you gave to Uli, I understand they were not informed about the preferences of the other electors. So they had themselves a fixed preference, but they didn't know what the preferences of the other.
They knew, yep,
of the other electors were.
They knew
the other voters.
Yeah, they knew where other voters were placed in the line. So if I take the line, if I take the distribution of preferences, they knew that, for instance, there was one person at 0 and one person at each location in the line. So they knew they could imagine how people would vote. So, for instance, in this three partitions, so in which there are three picks of preferences, they could imagine that, yeah, you know, the people on the right, they would vote for the right wing, the right wing in the line, let's say, the candidates on the right, and so on. So they could form clear beliefs about how other people voted, and especially after each election, they could see the results and they could see the votes, so they knew how people voted before, so they could adapt.
Thanks. It makes us wonder whether there is a kind of equilibrium strategy thinkable in that version of the game of voting.
Yeah.
Good, thanks.
Thank you for the question.
Hi, yeah. Can I ask my question? So, I hope I'm not misunderstanding, but because you're testing participants' understanding of the voting rules, but the understanding would also depend on how you explain the rules, right? So I'm just wondering, if you repeat the same experiment, but you explain the same rule in a different way, then how that would affect the result. Yeah, so
Yeah.
I guess my question.
Yeah, go on, sorry.
Yeah, I mean, I don't know if I have a specific questions, but those were just my thoughts. Yeah, so like maybe I guess the question would be, do you have any plans in the future on like comparing between different methods of explaining the same concept? And like,
All
yeah,
right, so
that'd be interesting.
so in this case, so our really struggle, our aim was to make the instructions as clear as possible. And yeah, of course, especially our instructions were not extremely long, and they were even quite visual. So in the case, for instance, of the tie-breaking rule for majority judgment, we did really give a little video of how it works, or we gave pictures, and so we made really our best, because of course one critique would be, okay, you were just not clear. We do not, but we can't even say that this is the optimal way to explain things. Of course, this is an empirical question itself. And yeah, what you argue, whether it is interesting to study different ways to explain the rule, this is a really interesting avenue for future research, I think, because in the case when there are some more complex voting rules, there is definitely to be a better way to do it and a worse way to do it. But this is not what we test. We have a fixed way to explain, and we just test this. Thank you for your question. Don't know if you I was right. Yeah.
Yes, thank you so much for the explanation.
Klaus?
It's a bit of almost a follow-up on the last question. Is it clear that this is the understanding is kind of an upper bound you provide in the experiment? Because you would, if in reality, I think in general for voting rules, if something comes new, it's almost like a paper exercise. You have to very kind of intellectually, it's almost like a whatever student. You're in the position of a student. If something is a voting rule which is used regularly, you learn it from understanding. Plus, of course, candidates can convey to voters, okay, if you want to vote for me, vote in this way. So it will be part of kind of embedded in the practice. So from that, I would understand that, expect that people can do quite a bit better in practice. They may not even explain exactly how they do it. They may be able to do it better in practice than they would do in a lab.
Yeah, this is a really good point. So I think I answered. So there are, I think, 2 points within the same question. So first one is whether then eventually candidates will actually give voters an hint of how to support them the best. However, I don't think that even in that case, it still might be that people do understand the voting rule and they are not actually empowered in a way because they simply follow what a party tells them to do. So that's I would still prefer the case in which a voter understands the voting rule and can act by himself, let's say. And for repeating, that's for sure. I mean, the more we repeat, the more we vote, the more we probably will understand the voting rule. What I can say is that in our lab experiment, people did try the voting rules before the actual vote. They got practice rounds, and so they really simulated already the case in which they get quite a bit of an experience with the voting rule, and still there was a misunderstanding. So that's why we say it's an upper bound. But yeah, then as in any lab experiment, the question is, will this be valid externally? If for 10 years or 20 years we vote under the same voting rule, will we understand the voting rule? Yeah, this is an empirical question. Yeah. I hope I was clear.
Thanks.
Thank you.
We are running out of time, but I want to ask one little question. You mentioned that the kind of setup that you did could also be used for other voting rules. I guess I'm asking for spoilers for future research you already have planned. But if you look at voting rules, such as in the first talk we've seen, Condorcet methods versus instant runoff voting, etc., would anything change? Do you have thoughts on generally how to adapt the approach?
Yeah, this is a good question. I think that this setup here, which comes actually from another experiment, like another paper from Van der Straeten and co-authors, can be applied indeed to any rule you can think about. So students in the lab will vote, will have some preferences, and there are some candidates on a line. You can apply that to any voting rule and see how people vote. If they vote strategically, you can measure their beliefs about other participants. This is applicable to any voting rule you can think about. Then, of course, the comprehension questions about vote aggregation would be. I mean, we would need to adapt them. I do not have any clear idea on how this would work out with the other voting rules the other speaker was speaking about, but yeah, it's not just to say that this has potential and it can be done, and we might be doing it in the future. Yeah.
Okay, thanks very much. Let's send another round of applause to our speaker. Thank you. This brings us to the end of this seminar. We will meet again in the new year on the 5th of January 2026, when we will have two talks, one from Suvik Roy and one from Prasanna Ramakrishnan. See all of you then. And in the meantime, have a nice rest of December and happy holidays in due course.
Thank you very much. Bye.
Bye-bye.
Thank you. Bye-bye.
Bye.